Hello, everybody. Tonight we are getting started in sort of the second phase of the class where we're working with that. Uh, we're going to look at interacting with a relational database from our software, interacting with a non-relational database. Um, Orient DB is kind of my preferred one, uh, but there are lots and lots of them out there. DynamoDB would be Amazon's preferred one. Um, As far as the JavaScript goes, the only difference is which object we instantiate as far as the database we're connecting to. We'll get to talk about that in a moment. Really like this night, the first night of class, because it's one of the first times that all the different courses tie together, right? Y'all were all required to take that, at least DBMS 110 class. A couple of the programs might have some other, your programs might have had some other database classes on there. Even though if you're a software development major, I guess that's not the only people that take this class. But if you're a software development major, you're required to take those data analytics classes and learn all the database stuff. And tonight is when we will actually apply that stuff in software development in Java for our case. So we'll look at that. Then what we would do in a working situation with database with this sort of stuff is split into two assignments this week. Because after our software grabs it from the database, we need to transmit it across the network. That's usually handled in JSON. So we'll grab that. Databases typically need to be strictly typed. That's important because if we don't have strict type, then our only option is to load the entire data set into RAM so that we can process it through and figure out what's in it and how it's divided up and all of that. So those who've seen the key value pair non-relational databases like MongoDB, things like that, it looks a lot like JSON on the strict type stuff in there. Can need that for the databases. And then when we go to transfer it, transfer it across the internet and then quickly work with it on the other side, we put it in JSON form. And that is usually handled in a RESTful API. REST is acronym for representational state transfer, the protocol on which the internet is built, basically one of the main protocols. But when we send data across the internet, that's referred to as a REST API. That's one of your assignments this week. We kind of did that in class a couple weeks ago. I won't still do it in class, but the assignment is just following along the video. A video tutorial that I think is about 45 minutes long. So when you go to your homework for this week, if we run out of time to do the REST API in class, you go through that steps because we did that earlier. Make sure you give yourself 45 minutes to follow along their video. A 45-minute video, you might need a few extra minutes to follow along, right? I'm sure at this point in your study, everybody has at least a rough idea of how long it takes you to follow along a video, right? Sometimes we have to pause and type some stuff and then rewind the video. You don't know the process. Make sure you give yourself enough time in case we don't get through that example tonight in class. We did look at the Spring Boot thing. It just loads in Spring Boot, and basically the default version of Spring Boot application is a REST API. The only thing it's missing is the data set that we want to transmit with it. And for your homework assignment, remember last week how we made those custom data classes? A bunch of different ones. Use that. The custom data class you made last week, use that as for your data set of the REST API. Then you don't have to make a new data thing. You'll just copy and paste that little file over there. And you might have to change the package name, but everybody did that assignment, so that should be fairly straightforward. Also, next Wednesday, there is a career fair that's IT oriented. It's at lunchtime at 12 to 1 in the Oval Commons. That's the old library. The big glass windows that face the interstate, That's probably the easiest way to give directions because most everybody around here drove up and down the interstate. So you know about the big glass wall you can see from the interstate. So even if you don't know your way around campus, you can probably find your way to that wall, even with the construction and stuff. But it's gonna be in there and there's extra credit points. I put it in both module 5 and 6 because it's on Wednesday. So I figured everybody was gonna look at the module 5 stuff on Tuesday night when this week's homework assignment is due. And that way it will remind you that that thing is the next day instead of putting it on. Instead of just putting it in module 6, but it's the same page, it's what I put in there. Go to career fair, dress appropriately for job hunting, the standard for going to a career fair, and take a selfie while you're there at the career fair. And then let me know who you list out the people you talk to, the companies you talk to, or whatever. Should be straightforward, but it's worth half as much as a homework assignment. So you get 15 points extra credit, or 17 points extra credit. A homework assignment for all 35. So it's like half of a homework assignment. It seemed like there was something else I was going to talk about, but it didn't make my notes here. So maybe I'll just randomly remember what the other thing to talk about was, because I must have just opened up my notebook and wrote it on the wrong page. But it's definitely this is the only class on campus right now for like the last 10 pages or so, all say SDEV 200, so I might have accidentally wrote it on the wrong page. But if I remember what it is, I'll bring that up. So first off, I want to look at relational databases. And for the note, really for the lecture this evening, I should put relational in parentheses because our example is for a relational database. But the only difference to work with a non-relational database, like we're going to work with a MariaDB, which is one of the versions of MySQL. And if you wanted to work with DynamoDB on AWS instead, or AWS's DynamoDB, the only difference is you would use a different driver. You would put a different driver in there and then use the syntax for that database. We'll see that before long. So just a quick review on this. Everybody's had that, right? I know everybody on the Zoom call had that. Yes. With me in the spring. So just a quick recap because there's 2 people that are going to be watching the video later. So relational databases. We need a highly organized, nice way to store our data. In our modern world, we have lots of data, right? That's the biggest one. That's the biggest number. So everything we've done so far with our software will probably fit nicely on our CPU, right? All the software we've done in classrooms has to be specifically designed to fit in our constraints. So it's all things that we can work with on our CPU. The other day we looked at persistent data and flat files, but sometimes we need to store large amounts of data. I think everybody's aware of this. And so like your assignments in class, homework assignment this week, and then the final project, your data set was probably something that you can take that whole, take that whole data set and shove it all into RAM and have no problems whatsoever, right? None of our final projects are going to get that big. But in the modern world, there's some very, very large data sets. What's the typical, what's the expected size for a CPU or RAM these days? Well, the cheapest one from Walmart, and it has 8 gig. 16 gig sound reasonable?
Mine's like 12.
It's 12, 16. When we get up to 32, we're starting to talk about nice game computers, right? Mm-hmm. So 16 gigabytes of RAM sounds like a lot, but modern data sets are often measured in gigabytes, not gigabytes, gibby. Things that we measure in gigabytes are not going to fit in a 16 gigabyte RAM hard drive. So we need to break it down. We need a small subset. We have to get just the subset of the database that we want. Our entire data set's not going to fit. So, I guess for the picture, we're trying to do sort of a size thing here, right? This great big database picture isn't going to fit in this little bitty CPU picture. So we need to filter down to just the part we want. I'll try to draw like a little cube. And then that's the part we want to bring over. But we want to do that very, very quickly. Come from storage and everything. And there's a couple ways we can do it. Our most important terms, everybody's heard this before, is we have structured, if I can remember how to spell it, structured versus unstructured. And there's several layers in between of semi-structured data. Right, I had the DBMS1 thing class, so I believe you had an assignment on that, on the stuff in between. But structured data is where we have the same thing from everybody. That's like filling out a form. Everybody fills out the same form, so we have the same information about everybody that we put into the database, or everything we put into the database. Unstructured data is more like the stuff we could grab from social media. Right? We know one person ate lunch at Taco City and another person drives a Mustang and somebody else just bought a new pair of Nikes. And if we tried to put that in the table, there would be more empty cells than full cells. So that's unstructured data. Structured data fits nicely into a table. So that's where relational databases come in. Unstructured data, we need a different way of dealing with it. There are several different ones. This isn't a database class, but the general category for them is non-relational database. And those are quite a mouthful. So everybody in here heard of SQL, structured query language. So for our relational databases, we'll often just call them SQL databases, even if we're using Link or Postgre or something else to connect to them. We still refer to them this way. And our non-relational, we just call those NoSQL because that's a lot easier to say. These are the terms we would use talking to other IT professionals, and probably would not be the correct answer on a multiple choice quiz. So good talking thing. Structured query language gives us the way to filter relational databases. I'm not going to get into the NoSQL databases tonight. There's quite a few out there: DynamoDB, Cassandra, Bigtable. Lots and lots of them out there. And there's a popular one that's been getting more popular, an NRAM one. Red something. Has red in the name. I can't remember. Red Shift maybe? No, that's not it. Well, there's another one that's been getting very popular lately that is an in-memory database. So we never use. So that Red Hat would be an operating system.
I didn't know.
It's built off Fire. It's built off Firebase.
Yeah.
And a new updates on Firebase is what it is basically. But it's in RAM, so we take all those small databases and shove them onto huge servers in the cloud. Spin up lots of the biggest server we can get on the cloud, and just keep all of our data in RAM the whole time. Those have been getting more popular, or people have liked the idea for a while, But the cost of getting all those servers on the cloud has gone down, so it's become more feasible lately. We're still gonna look at the relational database this evening, SQL database. So basically what we're gonna do, our database over here uses SQL, and we're writing our code in Java for this class. So we just need to have our Java code run some SQL and get the results back based off that SQL code. Essentially pretty straightforward, just a refresher on what a relational database is. So each data point gets its own field. It's a field. Move the camera over just. There we go. I'll zoom in some too. I think every one of y'all has seen me draw this picture before. I'm gonna draw it anyway. So a field is like one particular cell. Related fields form records. Blue and blue. So we have a bunch of fields. I'm going to draw some small ones, some big ones, a medium one, maybe another small one. And it is strictly typed. That's one of the important things about both relational and non-relational databases. Is if we don't have that type information in there, we have to process the whole data set to figure out what we have. It's not like a JSON store. If we put all of our data in JSON and left it in pure JSON, there's some technicalities that we could argue whether or not it's a database, because it technically is, but our only option for getting that data back in is to load the entire thing back into RAM like it's a flat file and process it from there. It's more of a transmission thing with JSON. And that's where the REST API comes in. So the two things in the homework this week, we would realistically combine into one. We'd do all of this stuff, part we're going to look at tonight, and then we'd load that into a REST API to transmit it across the internet to show on a nice GUI or something. Related fields form records, and then related records form tables. What color do I have left? Red. So we'd have a whole bunch of similar records, which are, I guess, in common English, we would say rows of the same thing, that same structure. Like we give everybody the same form, and everybody puts their name in the first cell, and their age in the second cell, and the town they live in the third one, and their favorite food in the fourth cell, and we have the same thing about everybody. And then the last one, and then tables are related by common fields. So I'll draw, am I still on the board here? Yeah. I'll draw another little table over here. Has a completely different data set in it. A bunch of rows. But maybe this row, this one looks about the same size. Maybe this data and this data are actually the same. And in the picture, it looks like they're duplicated. And when we put together our text file, it also looks like they're duplicated because we have to write it in both places. But internally in the machine, we only store it once. We have two ways to refer to it. Then we have that relationship between them. And with our strict types, so we know exactly where every piece of data starts and ends. We know exactly where everything is. We don't need our entire data set. I'll use blue. So maybe we know this one right here. What did I say a moment ago? Maybe this is the age of the person. We know a certain age. We can use that as our starting point, follow the relationships over to this common field, and follow that over to this other table. And we could find this data point by only knowing the relationship. We don't have to worry about anything else in our table. We don't have to worry about any of the data in here, just our starting point, and then the schema of the database. Y'all remember that word. All we need to know is the schema, which is the relationships, and we can follow those relationships around and grab the one data point we want and completely ignore everything else, no matter how big it is. So we can filter it very, very quickly. And there's similar things going on in non-relational databases. Usually when they show on GUIs, we often still see them in table form. And the biggest difference is it's unstructured data. So in a table, with unstructured data, we would have more empty cells than full cells. Whereas in a regular relational database, ideally everything should be full. Empty cells cause problems. But that's the idea of a relational database. That's storage, long-term storage. It gets very, very large in our modern world. So, good. I think everybody's seen that before. We don't need to spend a lot of time talking about databases. I just want to do the quick recap on the key points and some terminology. Has everybody seen a little bit of SQL? You're in the SQL class next semester, right? Hopefully, I haven't looked at the enrollment. It's still really small. You need it to graduate. Okay, yeah. If somebody needs it to graduate, it'll run with one person. So yeah, the cutoff numbers don't matter if it's the last batch you need to graduate. So for the others of you, remember at PBMS 130, the SQL class, the database class where you are just programming the database. I mean, it's a programming class. You're spending the entire semester on SQL. That's running the second 8 weeks. Learning that really, really well if anybody's interested in taking it, because it's really low enrollment. Somebody needs it to graduate, so it falls under different criteria than other classes where I have to look at numbers and alternatives and things for canceling classes. But that's getting distracted. Everybody's seen a little bit of SQL before, so we're not going to do much this evening with it. When I'm getting ready, I did create the database, create a table, insert some data. Those are a mess. There have been a number of objects built over the years to try and simplify that, but even with the objects, insert queries. Insert queries can be difficult. I think everybody remembers insert queries from your database class, right? We have to build those and dynamically in software. So we'll do a couple of those and then a couple select queries. And talk about a security issue, because y'all may have heard of SQL injection. Everybody heard of that? I keep referring to the REST API where we're transmitting data across the internet. You should see the natural extension of that, we are requesting data across the internet. And the way we request data, like if we're not careful, we could give people inadvertent access to our database. It's actually really easy to avoid. All you want to do is you don't take the entire query in as a frame. Because if you do that, then anybody can pass in the entire query. you just take in parts of it, you just take in a couple parameters, like the one we're gonna look at, actually. And jump into preview, and I don't think I deleted the correct example yet. So to avoid SQL injection, unlike other security things, right? People over in the other lab this evening, they spend all their classes learn all the details to protect computers and steps that can be taken. A query injection is a little bit different because only the programmer that developed the software can stop the query injection. If it was left open, there's nothing the cybersecurity person can do to block. So that is one of the most important cyber security ones to worry about on our side. And if I jump ahead to preview what we're going to look at in a moment, so like this connection thing that does some queries, this is basically what we have to do to stop it. Notice all those parameters, and then we just build a select group from those parameters passed in. So instead of saying, instead of passing in one long string that is a select query, select name and age from the people table where age is less than 19 or something. And we don't want to be able to pass that whole thing in. We break down into pieces. They have to say what table, specifically what fields or what condition. And that actually goes even further. The reason I mentioned this, I think it was after I started recording, like Humana, Yum has moved a lot of the operations to another city, but they still have a large office in Louisville, UPS, and a lot of them. All of your select queries do this, and they will hire programmers to work 40 hours a week just to write functions that do not take in any parameters. And that way, the only way to create that select query is from the programmer themselves. So that's the best way to block query injection, is that only the software developer that has access to the database have direct queries, period. Everybody else is basically limited to what amounts to submitting help desk tickets. Like, yeah, I need a query that gives me this information, and then one of the thousands and thousands of programmers that they hire is well places like Humana hire programmers like hospital secretaries. One of them will write that particular query and then run the query. So you just sit there all day long doing this. So this is a very common thing. There's also another reason, another thing I'll take this example. Since that was from my example, I should probably oh, I didn't save it. Okay. As you say, I should probably not go changing my prep example. Oh wait, it's open on my other computer. I'm gonna do it in Ant this evening, and we will manually work with the libraries. At the end, I was planning on opening a Maven project and showing you how to do it there. For that, it's just a dependency. But let's look at the libraries, because this is also something that will show up in other places. So I'm going to create a new application in Ant packaging, because we have to do this stuff in a lot of places. And for MySQL, the one our example is going to be with Maven, all we have to do is tell the Maven repository we're working with MySQL database, and that's common enough that it'll handle everything else. But that's not always the case, and we haven't worked with anything that's not part of the default installation of Java yet, right? We haven't brought anything in. Everything that we've worked with was installed in Java 20 when we started the semester. Oh, and remember, Java 21 comes out next Sunday. So Java has some big updates, a lot of which were specifically designed to make it easier for new people. But we don't want to be beta testers in a classroom. That would be bad. So Java is getting easier on Sunday, but there's probably quite a few bugs to work out before we actually do it all that way. MySQL connection, I'll call it. So there's a new project and I did it in ANT so that we can see how to work with packaging. Again, MySQL is common enough that Maven and Gradle would know that, but that's not always the case. Sometimes we will have to bring in the driver license. Before we go get the driver, if we go to services, notice that NetBeans knows that we have a MySQL server, a port 3306, so you should have one. That's the one I asked you to install on the Jamf server. Everybody remember doing that at the beginning of the semester? We've been automatically running Tomcat in the background when we look at JSP pages. But this time we're for tonight's stuff, we'll need to actually go in and start our MySQL server. That would be enough for the program, but we probably want to look at it as well. So go ahead and start the Apache server as well. Put in MySQL start. Okay, I guess I thought I clicked the button and then it wasn't running. Hopefully it won't crash on me. But go ahead and start those two. Minimize that to get out of the way. Well, we can see right here on the control panel that MySQL is a standard port number. It's on 4306. Our service already knows about that. It knows about web server layer. The Tomcat servers there. We use that a few times. It knows about Maven repositories. We haven't really looked at any of this stuff. On mine, it knows I have Docker there. And the Docker assignment is next week, so you may not have Docker installed on your computer yet. I don't think the button's there without. The button used to not be there until you installed Docker, but they may have updated it. It's common enough. But there's lots of things NetBeans knows about. So we have that MySQL database. We're probably going to want to look at stuff. So once it's running, if you open a browser and localhost, port 8080, that was the Tomcat server. So we just want to go to just localhost. It's actually port 43. Or sorry, port 80. Port 80 or 443. I'm on 443 right here. But localhost is the Apache server. If we go to that, there's a button for PHP MyAdmin, which is just a popular open source GUI for working with databases. Oh, mine was already signed in. I thought I signed out. If you have not, changed it, default MySQL access. The username is root, and the password is an empty string. If you haven't changed it, if you've changed it, hopefully you know what that is, because obviously we'll need the password. Our software needs the password. So ideally, in a realistic situation, you would probably add a new user to your database. Where was that? That's under MySQL. We go over here. There's a user table, and right now there's the root user, and that's it. So in a realistic situation, you would probably go in here and add a new user that's like Java programs or something that only your Java code has access, and then manage all the permissions. And obviously we're not getting into that this evening. Just I just thought I'd mention it for the sake of realism. Things you would definitely want to do anytime you're not under tight time constraints. So we will need drivers. When they made the Java programming language, they knew that we would be working with databases. Nobody had any doubts about that or anything. They knew for certain we'd be working with databases. So it would be nice to include those, except that it kind of requires a custom driver for every database. Where in a MySQL database, we need a driver built specifically to access a MySQL database. If we're on Postgre, we need a driver specifically to access Postgre database, or Mongo, or Cassandra, or Couch, or whichever one we want to use. There are lots and lots and lots of databases out there. Apex, whatever one we want to use, we need a specific driver. And so obviously trying to include all the drivers in the default installation of Java would just be too much. It would make it very, very large. So those are kept as external modules, which throughout this class, we've asked about Python and everybody said they've seen Python before. So if you're all well aware, most of the Python language is an external module. So you probably got used to working with those in that class. We're going to be working with MySQL. XAMPP has XAM. X is cross-platform. The A is Apache. The M is MySQL. So obviously we're going to be working with MySQL. So we need a MySQL driver. And I always just go search for it. And in particular, it's a Java. What's preview in there? MySQL. Okay, yeah, we're gonna look at that. I don't know why Google's trying to tell me. Should be doing it in Maven. I'm gonna show something else. We should be doing it in Maven. But if we do it in Maven, we'll miss something that we will need elsewhere that there's not an example of in the class. That's why we're doing it in A. A Java database connector. So a MySQL JDBC Java database connector driver. Just search for that, and it should be right near the top. This is MySQL from MySQL.com. Downloads the connector. So to keep it organized, Oracle also decided that instead of doing that, Oracle does make the connectors, so they might as well be the official thing. But they have the databases distribute them. That way people don't go to like the Oracle site and download the wrong one. So they sent the MySQL database to MySQL to distribute, and the Postgre JDBC to Postgre to distribute to users. So just search for whatever database driver you want. Make sure you include JDBC. And then you should be able to just download it. We follow that link, or I guess for right now, I could just put that in the chat room as well too, right? For those on the Zoom call, you can just click the links in the chat. But it was the top results from the search. And just choose the operating system. You'll see there's several versions of Linux, because MySQL is usually on a server, and most servers are running Linux. At the bottom, the source code, we don't want the source code. We want the platform independent version. So just go here, select the platform independent version, and the zip file. Those are both zip files. tar is rarely used on Windows. It works. tar is used mostly on tar is used mostly on Linux, and zip is used mostly on Windows and Mac. But all three systems can work with both types of compression. But you're probably used to zip, or if you're used to working with tar files, you know what to do with them. So I'm on a Windows machine, so I'm going to download the zip. If you're on a Mac, I believe some people are on a Mac. If you just double click a zip, so it's even easier on a Mac than it is on Windows. They want you to sign up and stuff. So if you scroll down a little bit further, you'll see this just no thanks to start my download. Unless you have plans to constantly be doing stuff with MySQL and have your own username to put in the forums and things like that. That's what you would sign up for, but we don't need to do that tonight. We can just click that button for no thanks, just start the download. The download? Oh, yeah, I'm still not used to Google moving that up to the top. I guess it makes sense. It matches Firefox and Chrome and Safari. So now in all of our browsers, we look up at the top. But I always still try to look at the bottom. I just realized there might be something in the downloads folder, which I should not share on the video. So let me go make sure my downloads folder is empty. There we go. While I'm at it, I should probably quit Teams. I would go in here and stop Teams. That way I don't accidentally share confidential information on a screen share. Okay, there we go. So after you download it, should be a zip file. Just extract that. Right click and extract on a Windows, double click on a Mac. Unzip on the Linux. Or if you like using tar files, the tar is there. The difference between the two is compression. So it's when we put them in this, when we zip them up, no different when we extract them. Okay, and this is what we would do anytime we need something that's not in that default installation of Java, which is used, by the way, but we would just download a zip file, and when we go in here, there'll be the readmes and all of that, or you might go to GitHub and download the stuff from there, download from the repository, and somewhere in there will be the jar file. That's the Java virtual machine equivalent, which is a zipped folder full of machine language. Is what it is. But this is all of the Java code already built for us to connect to MySQL. We need to move this someplace useful, so I'm just gonna hit copy. Don't need any of the other stuff. You can see down here the source code is here if you want to look at that. But all we need is the finished version, the executable jar file. So just copy that and put it somewhere where you won't lose it. I'm going to put it in our project. You can see the one where I was getting ready is already here. I'm going to put it in our actual project. I'm going to come to the top layer here, and I'm just going to put the source code in the project. When we actually build a final version of software, we get what's in the build file, build directory, which we don't have yet. So we would only end up with the pieces we need from this. So that's often a good spot to put it, is in the actual project you're working on. And leave that open because we can see things better in the GUI than in the console here in Java when we make changes to our database. One quick step we need to do is now we have to tell the Java programming language about this. Which in an IDE is easy. If we do it all in a text editor and a console or a terminal, all in like a text editor or PowerShell, for example, you would just store the jar file somewhere and point to them in the module path, which we have to do the module path anyway. But in almost all IDEs, we can go ahead and make a library so it's easier to refer to. So, and that means if you go to tools, about halfway down, maybe a little over halfway down, you'll see libraries. And here is all of the libraries that came installed in the Java programming languages, all the things that are ready to import. All of that java.util is back in 6, and java.io was updated in 8, and those JSP pages will make all the stuff we import for that are in one of these libraries. And that term works really well. A library is a building full of shelves. The shelves are full of books, and the books contain information. So one library can contain lots of jar files. So we need to make a new one for MySQL. So I'm going to make hit the new library button and make one for MySQL or some other relevant name. MySQL seems like the most relevant name for us this evening, though. So MySQL, and make sure it's a class library. On the default installation of NetBeans, you shouldn't have any other options of making it a class library. So we'll create a new library, and then we have to add the jar files to it. Like we have a library, so we have to put books in our library. It doesn't mean anything. The library is just the building. So we'll add a jar file, and we just want to add that jar file we just put in the project. So if you're going to use it in lots of projects, it's probably better to put it on your computer somewhere where it's not going to get moved. And that way you don't have to keep making new ones. But once we have that, just hit OK. So new library, give it a name, add a jar file, and however many jar files you want. I believe our textbook talks about JavaFX. I know it does. Our textbook talks about JavaFX, so if anybody's just really wants to use a local GUI package to read those chapters of the textbook. That was removed from the language in 2018. But it wasn't deleted, so you can still go get all of the drivers for that, all the jar files. There's like 6 to 9, but really you need 6 of them, and then the other 3 are just very, very obscure random things that you'll never see. And then we need to set it in our project as well. So I'm going to come over to the project here. Right click on the project, and down at the bottom is properties. And we'll go to libraries, and you can see there's 2 ways we can add libraries. We can either add it to the module path or the class path. And we do have to do this in Maven and Gradle. This is part of Java, not part of the packaging system. We have to set the module path or class path no matter where we're at. It's just the example we have to go through this in classroom is MySQL, and that's common enough that Maven will set MySQL in any of our other databases. JavaFX, or usually it doesn't set it. It just MySQL that happens to. So we go to libraries. The difference between them, I wrote it down to make sure I can say. The module path is where the compiler lives, and the class path is where the Java virtual machine lives. So if the stuff in that jar file is completely finished, we aren't going to do any changes with that. We're not going to import it and extend any objects. We're not going to do anything in our code with it. We're going to use it as is. Then it would go to the class path because only the Java virtual machine needs to know about it. In our case, we are going to do stuff in our code that needs to be compiled. So the compiler needs to know about it. The compiler needs to know about it. It goes in the module path. So just hit the little plus sign there and add that library we created. And we are looking at this as a database, but hopefully everybody sees that even that including libraries is not the database part, right? We had to do that for the database part, but that's something that shows up a lot. There's lots and lots and lots of Java code that was written over the decades when Java was the most popular programming language in the world that is not part of the official language. Is not part of that default installation of the language. So there's lots and lots and lots and lots of libraries out there we might want to use. That's the steps for all of those. Get up to the module path, and all your IDEs will do that. And the zoom buttons won't get out of my way. We hit OK. And real quick, I'm gonna start PowerShell. Terminal. Documents. / NetBeans projects. And MySQL connection. So here's where we are. Here's where that library is. So what we would do to set it, I'm going to highlight this path where I'm at. Notice how all our source code is right here. Right? There's that SRC folder, and then inside of that's going to be a bunch of package directories that we call packages. And inside of those is a bunch of Java files. When we looked at the compiler, we went to that one particular place and did it one spot at a time. So normally we would run our here, we would say Java C, and then instead of a file.java, we would say like stores / package / asterisk. So compile everything asterisk.java. So we won't do that. Compile all of the Java code in that source package. We would do that right here. And when we do that, we want to add a parameter, and this is where the module path and class path come in. So -- module - path. And then we would paste in our directory. Like always, and things are space delimited in terminals, so if there's any spaces in your file names, you have to have quotes. If there's more than one module, like, let me copy just half of that. Maybe I have another module over here in documents. If there's more than one, it has to be in quote marks. And you put a semicolon and paste the other one. Oh, whoops. And what I just put here would error out no spaces. Full file path, semicolon, other file path. So no spaces between them, like oscillators. That's how you set the module path in the compiler. And same thing for the Java virtual machine where we actually run it. Hopefully the extension on that is obvious. It's just instead of the compiler, we are running the Java virtual machine, which means instead of a module path, we want a class path. But that one also happens to be abbreviated as -CP. You have two options, -- class - path or -CP, which I have never typed module path in as MP, but as I say that out loud, the fifth or sixth time I teach this course, it suddenly popped into my mind that I bet module path is abbreviated too, and I've just never bothered to type that in. So that's where we enter those. So everything we just did up to here is for the language, anytime we want to use a library. You have to do it for every single jar file. That's why there's multiple directories on the module path. It point to every single jar file in the terminal. And that thing we did in the IDE, it just consolidates them. It just makes them easy. There's a way to package stuff together like that, or put them all in one folder and just point to that folder. Is basically the way to. That's what they did. Maybe copy of it somewhere. But we have the IDEs. The IDEs make tools. All of our powerful IDEs would have those same things, just in a different order. Maybe we can start by building our data object. So I'm going to come up here to the package. Right click on the package and create a new Java class. And I'm going to call it record. In the example last night, I just called it data. So hopefully I won't confuse myself. But record would be the proper name, right? What I wrote on the board as far as vocabulary a few minutes ago. And we need to represent our records. Everybody here has had me in class before, right? so you all know what the default class example of a data set's gonna be. We're in a database, a MySQL database, so we need that unique primary key. So we'll probably just use auto increment an integer, the easy way. What we pretty much always do. Private int called person ID. I think everybody here has seen my default data set before. People, and each person has a name, age, and town that they live in. And then an ID so that we can do all the database stuff, but we're only gonna make one table, so we really won't use that. Then the rest of our stuff. For good form with encapsulation, we want our data field to be private. We'll have names or strings. Private integer for an age, because after we pass 2, we don't give fractions anymore. I guess like 3 and 4-year-olds might give the fraction because they're used to hearing people say that, but usually by the time kids are 4 or so, they've noticed that adults don't give fractional years and figured it out on their own. So integer for an age, and then town. Private data set, data field for a string called town. And let me say that same thing I just said. A private data field of a string called town. Well, that was one of the vocab words I put on the board earlier about relational databases, right? Called this a data field. And then the Java code, I called it a data field. And y'all have seen everybody on Zoom call had me for the 110 class. I know Larissa's seen it. So y'all have seen how to create a data field in a SQL. It looks very, very different between Java and SQL. But it is not a coincidence that we use the same term for that. They look very different in the text files, but back to this picture on the board, the text file is not what goes to the CPU, right? The text file is modified through several times before it gets to the CPU. So it is not a coincidence that we use the same word for that. This is a data class, so let's just make our insert some constructors. Alt insert, put in an empty one. Alt insert constructor, put in a full one. And notice the full one has the ID. That integer, that's going to be a primary increment, a primary key auto increment by the database. So this is the constructor the database will use. But we also need another constructor that has all of the fields except the integer. Right? Like when we go to insert data, we just want to send the name, age, and town, and then let MySQL figure out what the ID is. That's the only reason I included ID. We're not going to make multiple tables in our class example here. Yeah, we're not going to make multiple tables, so we don't really need the primary key to tie them together. But in a real situation, you would. So remember, you're always going to need the database is probably going to have a different constructor than you will. I can say it that way. This is the constructor for MySQL, and this is the constructor for Java, depending on where the data starts at. Whether we're sending it, retrieving it. What else are getters and setters? Like all. And this is just for transferring our data, so that's good. I'm not going to do a 2-string right now. Might do a 2-string later. But I don't want to do a 2-string. I'll go ahead and say it. In order to preview what we're looking at next week. So that default 2-string that y'all have probably seen by now, where we have something that doesn't make any sense. So we need another class where we will put all of our connection stuff. I'll call it database connector. Whoops, one word. In Pascal case, all the Java naming conventions. Database connector, so it has a nice descriptive term. And we will start putting things together in this one. Oh yeah, so hopefully that name makes it obvious what it's doing. Connecting to the database. So there's three things that we have to have in order to connect to the database. We need the URL. Where's our database located at? We need the username, and we need the password. So for our class, we need to set those up. Private string URL, private string username, and private string password. And those are just added fields. We'll pass in the particular one we want later. Then we need a constructor for it. And when we get over to the main class, I'm going to set those up as static fields, static final fields, because they're not going to change, right? We're always going to be connected to the same database. There's no need to have a variable. Right? We don't need it to change. We can make it static because we're only connecting to the one database. We don't need it. We don't need one that can change. Another use for that static keyword. And I'll pass all of those in. So I'll just make the constructor with everything. I think that'll be enough for the thing. And I think we have enough time real quick to go ahead and create our database. We take a break. Let's do public int. Everybody said they had the database class. Remember what MySQL returns? Everybody remember MySQL return? 3 rows affected, 0 rows affected, number of rows affected. So MySQL returns an integer. So it's probably the most logical thing to do in our code is to return that integer and get back to MySQL. 0 or positive, we can do 0, like this is going to be the create table. So we'll create the database itself. We'll create a table for it afterwards. And this is why there's lots and lots of work. When most of the rest of what we do this evening, we'll probably pass in parameters. There's lots and lots and lots of work to go sit and write Java code that makes a method that does not take in any parameters and develops a particular query. That is the ultimate protection against query injection attacks. Excuse me. Protection against query injection attacks is don't leave a spot where people can pass in parameters. Only the software developer can pass a query to the database. Which in our case is going to be easy. So we want a string. I'll call it a query and create database if not exist. People. Oh. And SQL ends in semicolons, right? Create database if it doesn't already exist. People, end of instruction, or end of SQL instruction, and then after the quote mark to finish the string, then we need the end of Java instruction. That's one that you get used to it and do your homework this week. You're probably going to miss a bunch. We have to have both semicolons, one for SQL and one for Java. Now we can run this, and running it is all going to look the same. We'll have a try catch block. And I'm just gonna do the easy catch exception overall everything. And we're returning an integer, so I'm gonna create an integer called result. And for the catch, if something goes wrong, I'm gonna return -999. Because MySQL will return 0 or more if it's successful. And MySQL returns a negative number if it fails. So if the code errored out, we get back a negative number. So we can just follow suit here, and if something errors out, we'll return a negative number. We need an import. I'm going to go ahead and type the import manually. So if we scroll back up to the top, we want to import Java dot SQL. That's the jar file we brought in. And the jar file has lots and lots and lots of objects in it. We will probably need a bunch of them. So I'm just going to put the wildcard there and select all of them. Which again, the reason the asterisk works here is because it's a SQL character. Just like how it's not a coincidence that we use data field for both our Java objects and our relational databases. Or everybody said they saw Python before, so I might remember in Python there's a whole bunch of things that look a lot like SQL statements. They're not coincidences. But with our wildcard works here as well. So that will import, that's all the new library. So we're going to import everything we need. First thing we need is a connection, and it is called just that. Connection type of data, I'm going to call it con because that's just a lot easier to type. Over the years, I've found that if I type connection repeatedly, I tend to make typos. So I do abbreviate these words. And whenever I see examples, even on tutorial sites that go on at length about Java naming conventions, they still tend to abbreviate con and state connection and statement and result. So it's a common thing, like we typed out so much typos did that. And to create that connection, we'll have our driver manager, which is another one thing we imported, get connection. And you can see on the predictive text here, the bottom one, get connection is overloaded, and one of them is the URL, username, and password. Those 3 data fields we set up earlier. So when we get connection with URL, username, and password. A little bit longer. Oh, the semicolon didn't fit, but there's that line. There's the whole line. So connection, the name of that object is, or name of that data type is quite obvious. The object is con, but a connection, and then it's just driver manager.get connection, and then the details that we need in order to connect to our database. Then what we're going to do, we're going to create a statement. Run a statement, I'll abbreviate it STMT, is con, that connection dot create statement. Yeah, we just want that blank create statement. So that initializes it. And then we can use that statement, STMT dot execute. If I start typing execute, you'll see we have lots of execute options. Execute string, so execute a query in the form of a string. We already wrote our query in the form of a string. Execute batches, large updates, execute query, execute update. Usually we want to do execute update. Execute update for almost all of them, except for select queries. Create and insert are updates. And obviously select is not a, selection isn't an update. So execute update for insert and create, and execute query for selection are the two that you want to use most often. Execute update and pass in that query. That, and if everything worked, that MySQL should return an integer. Execute update is the ones that return an integer. 3 rows impacted, 19 rows impacted, 0 rows impacted. Otherwise, it's an error message, which it will go ahead and connection will go ahead and kick out of the try catch block, and then we'll handle that negative number here. Then close things in the opposite order we open them in. So we'll close the statement, and then we'll close the connection. And return. Oh, I can't remember what I called it. Return that number that MySQL gives us when we get to if we get all the way to the end successfully. Well, that makes sense. That took longer than I thought, and which means it's probably going to take longer than I thought to call this method. So we're probably going to take a break, and then we'll start. We'll call this method, and if everything runs successfully on it, we'll do stuff. 10 minutes sound good to everybody? Good. Affirmative here in the classroom. And then we will, when we get back from the break, we will finally be ready to start putting things in our main method so that we can manage our database from the software. The very reason you all had to take that other class. And the number one thing that software developers are hired for. So looks like it's 7:15 on the dot. So we will get back to it at 7:25. I'll see y'all in just a moment.